Okay, so I did not paste in the original problem, so I'm going to read it to you. Hopefully you have it in front of you on another screen from the lesson page. But this is what it says. Okay, write an equation to model each situation, then solve the equation. So first we got to write the equation, and the first thing that we should be doing is defining the variable they call it. What does the variable in the equation represent? Okay, so here's what it says. Number 19, employment. You have a part-time job. You work 3 hours on Friday and 6 hours on Saturday. You also receive an allowance of $20 per week, and you earn in total, doesn't say this, but in total, you earn $92 per week. How much do you earn per hour at your part-time job? So the idea is that you take the amount of money that you make on Friday, the amount of money that you make on Saturday, and that extra $20 that you get for allowance, and all of that together is equal to $92 per week. Now, H. What does H stand for? Well, it's not the amount of hours that you work, because for number 19, they're telling you that you've only worked for 3 hours, so there's nothing variable about it, okay? But how much do you earn per hour? That's what H is. So you can see up at the top I've written here, let H equal the amount you earn per hour. Your hourly rate is what they call it, okay? And then we need to write the equation. Now that we know that that's what it stands for, it says, basically you say, I work 3 hours at times how much I make per hour, plus on Saturday 6 hours at that many dollars per hour, okay, plus this extra $20 that I get for allowance, and that sums up to $92. This is an equation that we can now solve. What do we do first? We combine like terms. These are both H terms, variable terms in H, okay? So we combine those together and we get 9H, and everything else stays the same. Plus 20 equals 92. And now we're undoing the equation to isolate the variable, and we have to do inverse operations. First we do the inverse operation on plus 20. What's the inverse operation of plus 20? Minus 20. So we write 9H plus 20 minus 20 equals, and if we subtract it from one side, we subtract it from the other. So this 92 is here, and then 20 taken away from that. Now we're again at a stage where we need to combine like terms. The like terms on the left are positive 20 and negative 20. They're inverse. They're opposites, really, right? So they combine to 0. And that's the point of subtracting 20 from both sides, is to make this become 0, to leave just 9H. Okay? What happens over here? 92 minus 20 is 72. So now we've got 9H is equal to 72. Okay? What's happening to H? H is being multiplied by 9. So the inverse operation of times 9 is divided by 9. And we divide both sides by 9. This becomes then 9 over 9H. And 9 over 9 is 1. 1H we write as just H. Okay? And 72 divided by 9 is 8. You need to get good at your multiplication and division values. And by the way, if you're not so great at it, I have some triangle flashcards that you might find enjoyable to practice with to get up to speed. You come in and talk to me about that. But 9 divided by 9 is 1, so just 1H or H, and 72 divided by 9 is 8. So H equals 8. And I didn't box that here, notice, because that wasn't the answer. Because what was the question? How much do you earn per hour at your part-time job? And you earn $8 per hour, so I have as an answer, you earn $8 per hour. That's the answer to the question that they asked. Okay, so if the problem represents some situation, even though this is what the variable is equal to, that might not be the answer. Okay, so we write it here. Now, let's just prove it. Prove that that's correct. How do we do it? We take the original equation that we wrote, and we write a proof for it. Proof. Now, fun fact, if you wrote the equation wrong, you could solve this and get a number that's not actually the number you're looking for. And then because you're plugging it into the wrong equation, the equation that you wrote, you might end up, the proof might work out and it still might be wrong. So you just got to be careful that you first write the equation correctly, because otherwise you'll find the answer to your equation, but it's not the equation that should be there to solve the problem. Okay? Anyway, how do we do it? We write the original equation unchanged. That's the first part of a proof. What's the next part of a proof? We rewrite the original equation unchanged, except the only change you make is that wherever there is a variable, you put parentheses and the value 8 in this case. Okay. A mistake you might make here is, and I move this back up, you look at this, you say, oh, the first thing that I should do is combine like terms. No, that's what you do when you solve it. But that's not what you do in the proof. The proof always has the first two steps looking exactly the same. First step, original equation. Second step, exact same original equation, but instead of variables, you put parentheses and the value that you believe the value. From there, now we can use order of operations to simplify it, okay? So we need to do this multiplication. And since these are separated by an addition, that's something that happens in a later step. Doing this multiplication here and this multiplication here at the same step is fine because they will not interact with each other to affect each other, right? The other option would be to like do this first and don't do this yet and write that the same underneath. Then do that on the second step. But there's nothing that would change. It wouldn't affect it if you did this and this together since they're separated by something that happens in a later step. So 3 times 8, 24, plus 6 times 8, 48, plus 20 equals 92. These two things are the only two things that got simplified to that got simplified to that. Okay. Now following order of operations, we come from the left. What do we run into first? We run into 24 plus 48, and we get 72. Write everything else the same. Plus 20 comes down. This is still here. And of course, 72 plus 20 is 92. So you get 92 equals 92. Check. Now, just a note, you can definitely know that you're doing a proof wrong if the proof starts out, the original equation, I should say, starts out with something like equals 92, like this does here. And then at the end, you don't have that number on that right-hand side like it started out to be. There's nothing this can be simplified in no way. It's already as simple as it can be. Nothing should change about that all the way through. This gets simplified once the values are substituted in, and hopefully they're the same. But if you start out with having equals 92 here and then in the answer, that's not what's down there, then you might have done something like add the same amount to both sides or otherwise do something that can happen over here but shouldn't happen here. If you don't know what I mean, come and check with me.